So yesterday we saw matrices, right? Is there any doubt from that particular topic? Is there anyone having a doubt? Whichever point you wouldn't understand?
No, sir.
Okay. Then today we will see determinants. Okay. So can someone tell me why do we actually learn determinants and what is going to be the application of it? I'm not asking about real-time basis. Generally, what are the kinds of problems you people do? Like where do you apply it in your NCERT you would have solved, right? Where do we generally apply it? See, suppose I give you a question like this. Okay, so what did I actually give you?
Linear equation.
Sorry, I didn't hear you. Can you be a little louder?
Linear equation.
So I gave you linear equation. So how many linear equations? 2 linear equations. Now the important question is, I gave you 2 linear equations in how many variables?
2 variables.
2 variables.
So I gave you 2 linear equations in 2 variables, right? So if I ask you to solve this, what all will you do? So what are all the methods in which you are going to solve?
Elimination.
You will do something like you think of elimination, you think of substitution, then you can think of the formula method. So you people know what is the formula method? You write something like this: x, y, 1, b1, b2, a1, a2, c1, c2, b1, b2. Write something like this, right? Oh, I'm sorry, wait. A1, A2, B1, B2, C1, C2, again A1, A2. You would have seen the method like this, right? So you write it as x divided by A1, B2 minus A2, B1 is equal to y divided by B1, C2 minus B2, C1 is equal to 1 divided by C1, A2 minus A2, C1. Have you seen this kind of a method? Sometimes people call it as cross multiplication. You have seen it, right?
Yes, sir.
So sometimes people call it as cross multiplication method also. So when I say linear equation in 2 variables, actually it is, see, if you look at the inner meaning of it, they are nothing but 2 straight lines. When I ask you to solve that, you are finding the value of x comma y, right? So if I speak about x comma y in terms of set, can I call it as ordered pair? See, look at the way. If I talk about this point x comma y, if I speak in language of sets, then I will call it as ordered pair. If I speak in terms of coordinate geometry, then what does x comma y mean? It is the point of intersection of 2 lines, right? In a similar way, is there any other way we can solve these 2 equations? Are these only methods that we know? The elimination, substitution, formula method or something, or cross multiplication, whatever it is. Are these the only methods that we know? The best other way, see, since the cross multiplication method is telling you something like this, the other way in which we can solve this problem is by taking the help of matrices, because matrices has something like multiplication, right? So with respect to a linear equations, what are all the parameters associated with it? So what is this is called as coefficient of x. 3 is the coefficient of y. X and y are the variables and 5 stands for constant, right? So is there a way where we can write this linear equation in the form of a matrix and perform an operation between those matrices such that you get the right hand side. Is there a way we can do it? Guys, are you able to understand what I'm trying to say? So 2x plus 3y is equal to 5 is there. Similarly, 3x plus 2y is equal to 7 is there. Now my question is, will you be able to take the help of all the parameters, that is the coefficients, variables, and the constants, and write it in the form of matrix and perform an operation between them? Can we write it? Yes or no? There are only two possibilities. One is you should be able to understand what I'm saying, or you should have not understood my question at all. Is it not clear? Is my question not clear? Are you guys there?
Yes, sir.
Yeah. Is my question clear or not? I'm asking, will you be able to represent the coefficients as a matrix, variables as a matrix, constant as a matrix, and create a relation between them?
Yes, sir.
Yes, sir.
How do we do that? That's what I'm asking. So what should be the matrix 1 that I need to take? So if I need to define a matrix with the coefficients, then I will write 2, 3, 3, 2, right? Into, I'm taking a column matrix x comma y. This should be equal to another column matrix 5 comma 7. Does it make sense? Can you check it? So what I'm trying to say is, the coefficient matrix multiplied with the variable matrix is going to give you the constant matrix, right?
Yes, sir.
So when you take the help of this, from here only we will take the help of the concept of inverse of a matrix to find the value of variables x and y. So that is why I was speaking about the variables x and y. So I'm coming back to the same point. When you find the value of variable x and y, you write it in a pair. Then in terms of sets, we call it as ordered pair. In terms of coordinate geometry, we call it as point of intersection of two lines. Similarly, in terms of determinants, we call it as solution of the equation. So whenever I ask you to find a solution of an equation, then I'm asking a question saying that speak about the consistency and inconsistency of the equation. So to put it in very simple terms, in your lower grade, you would have learned this thing, right? A1, so if I have a line like this, A1x plus B1y plus C1 is equal to 0. A2x plus B2y plus C2 is equal to 0. In your 10th, you would have definitely learned. So when can I say that these two lines are parallel? What should be the mathematical?
Ratio of the
Yeah,
coefficients should be equal.
A1 by A2 should be equal to
B1 by
B1,
B2.
or you
Not
can write
equal
A1
to
not equal to
C1 by
C1 by C2.
yes, that's right. So if I take these two terms alone, okay, if I take these two terms alone, then what do I get? A1 by A2 is coming out as B1 by B2. Now I'm doing a cross multiplication between them. A1 B2 minus A2 B1 is equal to 0. So what exactly did I do? Is it not like I've written a matrix A1 Is it not like I've written a matrix like this, A1, B1, A2, B2, and I have done a cross multiplication between them, right? So A1x plus B1 by, I've written a, what do you call, coefficient matrix. I've written a coefficient matrix. Are you guys able to relate it? So the coefficient matrix is written in such a way that the variables of the first equation are written in the first row. The variables of the second equation are written in the second row. So when I write it in this kind of a format, see, clearly observe, I didn't write it as A1, A2, B1, B2. This is not the way we have written it. Rather, I've written it A1, B1, and A2, B2. So first row consists of the coefficients of the first equation. Second line consists of the second row consists of the coefficients of the second equation. Okay, be careful with that. Then I'm doing A1, B2 minus A2, B1. If I need to give a, so Will I be able to relate these two? So this A1, B2 minus A2, B1 came from the knowledge of coordinate geometry. But matrix is telling that if I write them in the form of coefficient matrix, then I will be able to do a cross multiplication between both and subtract those results. So if I do that subtraction, what is the name of this according to this 2 by 2 matrix? What is this A1, B2 minus A2, B1 called as? This is what is called as determinant of the given matrix. Are you guys able to understand what is the determinant? Where exactly the concept of determinant actually came from? So to find the solution of an equation, when you take the help of matrix, the cross multiplication method is also telling us something. A1, B2 minus A2, B1 means you're doing a cross multiplication and subtracting the variables. If you need to give a name to it, then the name given to that particular variable in the case of a second, in the case of a linear equation in two variables is what is called as determinant. Guys, am I clear? So this is where the idea actually came from. Okay. So that's what would have been given in your introduction. You can just read it. You will be able to understand. So this A1, B2 minus A1, A2, B1, which determines the uniqueness of a solution, whether they are parallel lines or infinite lines or whether they are intersecting lines. So this A1, B2 minus A2, B1 is a very important parameter, right? So this is coming from the coefficient matrix. That value which is coming as a cross multiplication and the difference of the variables is what is called as determinant of A or det A, or sometimes we write it as, it is written in the form of modulus of A, but we should read it as determinant of A because here A stands for matrix. You will call it as modulus only if it is a number. Matrix is not a number, it is a collection of numbers and an arrangement. Right? It is a matrix, or sometimes we write it as delta. Guys, is the introduction clear?
Yes, sir.
Right? So if this is the case, see, first thing, determinant is a concept which you can define for what kind of a matrix. Yesterday I told you, right? Whenever you're reading matrices, when you're reading the different types, you need to understand whether it is a rectangular matrix or is it a square matrix. So determinant is always applicable only for a square matrix. So if I write the square matrix A is equal to Aij of order n, we can associate a real number called determinant of the square matrix A, where Aii is equal to ijth of the coefficient. I'm not reading out all these things. I'm putting it in very simple terms. If I write a matrix, a square matrix A is equal to ABCD, then you take, for a 2 by 2 matrix, you take the first diagonal, you take the second diagonal, cross multiply them and subtract, then that value is what is called as det A. So all these things you people know. So what are the remarks? For a matrix A, det A is read as determinant of A, not as modulus of A. Secondly, only square matrices have determinants. Right? So very simple aspect. Next comes the third point. So if I find the determinant of a matrix, if I need to find the determinant of the matrix of order 1, the determinant is nothing but the element which is present in it. So if I have a matrix A, then the determinant of A is nothing but small a, the element which is present. For a 2 by 2 matrix, I told you already, you have to cross multiply the first diagonal, cross multiply the second diagonal. First diagonal's product minus second diagonal's product is what is called as determinant of A for a second order matrix. Third, how do you find the determinant for a matrix which is of the order 3 by 3? Can someone tell me? So how do we do? Science students, you should definitely know it. We applied in cross products. In cross product, everybody knows. No, vectors also we applied it. Yes, so everybody should know determinant. So how do we do? You put a plus, minus, and a plus. Right? You write the first element multiplied with, what are we supposed to do, guys? You need to hide the first row and the first column. Then it is A22, A22, A33 minus A32, A23 minus, what should I write?
A22, A12.
A12.
A12, A12. So remember this, I'll tell you after we discuss minus and cofactors, I'll tell you what exactly is the meaning of determinant. As of now, just tell me the method. A12 into, what are we supposed to hide?
A21.
This row, sorry, this column and this row should be hidden. So A21, A33 minus A23, A31 plus A13 into A21, A32 minus A31, A22. Now I have an important question. This is how we solve every problem based on determinant. Now the question comes as, is this the only way we can expand it? So to expand it, I have multiplied the elements of the first row, right? I've taken the elements of the first row. A11 is the element of first row. A12 is the element of first row. A13 is the element of first row. From that, I took all these products and multiplied. If suppose I ask you to expand it column wise, is it possible for you? Is it necessary that we need to expand determinant only through row? Can we expand it column wise? Is it possible or not?
Yes, sir.
So how do we do? How do we do it? Suppose I want to expand it column wise. So tell me. I will take A11. So A11 should be multiplied with A22, A3 minus A23, A32. Right? Then I want to expand it according to this column. So how do I do?
Minus
A21.
So how did you know it is minus? So it is the order that we have to follow. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. Minus A21 into
A22.
A12. No? This should be hidden and this
A13.
A12, A33 minus A13, A32. It is always from left to right and right to left. This way first, this way second. Next. Next, what should I take? Plus,
A31.
minus, plus. Is it
A31.
plus A? So it is plus A31. Tell me with the sign also. Plus A31 into A12. I should hide this and this. A23 minus A22, A13. Right? So similarly, you can do it according to the second column. You can do it according to the third column. You can do it in any way you want. Right? Just for the sake of practice, we will do one more way and then we'll go to the next concept. Minus, plus, minus, plus. Suppose I want to expand it according to the second row. I want to expand it according to the second row. Tell me what is the answer. Minus A21. Why did I write minus? Because that takes a minus sign, no? So minus of A21 into
A12 into A33.
A1 to A33 minus A13, A32. Then plus A22 plus A22 into what?
A11 into A33.
A11, A33 minus A13, A31. Then minus A23. So minus A23, what is it?
A11, A32. Minus A12, A31.
A31. Okay. So all these are the outputs of the determinant of A. Now comes an important question. So the determinant of A, what is the output it is going to give you? So what is the output you are going to get? Are you going to get a matrix?
No.
Numbers.
You will just get a number. Is that number always positive?
No, sir.
It can be a negative number also. Okay, because you should, just because it looks like modulus, you should not have a confusion that it is going to give you a positive value. It can give out any value that you want. Okay, so generally when you expand it, no, these remarks are given for you to apply in the concept of properties of determinant, which is actually removed from the syllabus again. Okay, so for easier calculations, generally what we do is, but I hope you would have learned all these properties, right? They would have started this chapter in the beginning of your curriculum, beginning of the year, you would have learned all those things, right?
Yes, sir.
Yeah. So generally what we do for easier calculations, we will expand the determinant along the row or a column which contains maximum number of zeros. Okay, that is how we choose and do it. Similarly, while expanding, instead of multiplying by minus of I plus j, we can multiply with plus 1 or minus 1 according to I plus j is even or odd. In the sense, what they are trying to say, I hope you know, that is what we did actually. When a matrix is taken, this is the first element. So I is how much, j is how much. So both are 1, right? So you write it as minus 1 power I plus j will be the multiplication factor. So here, what will you get? Minus 1 power 1 plus 1. So it is going to be 1. That is why we start with a positive sign. Similarly, here it is a12. So it will be minus 1 power 1 plus 2. Minus 1 power 3, which will be minus 1. That is why we have a minus sign here. Okay. Next. Suppose there is a square matrix 2240 and b is equal to 1120, then it is easy for us to verify that a is equal to 2b. So that is how the matrices are given. Also, determinant of a is how much? Determinant of a is minus 8 and determinant of b is how much? Minus 2. Right? So if the matrix A is 2 times b, right? If the matrix A is equal to 2 times b, then what will you speak about their determinant? What will happen to the determinant? Can I write determinant of A is equal to 2 times determinant of B?
No, sir.
Then what will it be? So you guys look, no, determinant of A comes out as minus 8, determinant of B is minus 2. So minus 8 is equal to K times minus 2. If I write it like this, what is the value of K that you will get?
4.
You get it as 4, right? So 4 can be written as, see, 4 into minus 2. So minus 8 is determinant of A is equal to 4 times determinant of B. So when the matrix is 2 times B, what happened to the determinant? It became the square of it. But square, is it square always? There's an important property based on which you get. So what should you write? This 4, you can write, how should you write? You write it as 2 power 2, where this 2 base is coming from the K and power 2 represents what?
Order.
It represents the order. So if you know the order of the matrix, then the determinant will become the multiplication factor times the order of the matrix. Right? So I hope this also you people know. Right? So as I told you, properties of determinants is removed from your syllabus, so you need not worry about it. Anyways, this doesn't have connection to the next part of the chapter also. Okay. Similarly, determinants will also help us to find the area of a triangle in a two-dimensional space or a plane, two-dimensional plane. See, this also you would have learned in your lower grade. If I give you a question like this, find the area of the triangle whose vertices are 3, 8, minus 4, 2, and 5, 1. Okay. Then, how do you find the area of this? So I'll show you all the methods which you know. If I ask you to solve this problem using coordinate geometry, what will you guys do? Area is equal to half into x1 into y2 minus y3. You will have the cyclic format, no, y3 minus y2 plus x1 into y2 minus y1. So you will have a cyclic pattern and you will put a modulus. Oh, sorry, y3 minus y1 and y1 minus y2. Right? That cyclic x3. So this is according to coordinate geometry, right? So we also have learned the same thing using vectors. Did we learn or not? So if I take this point as A, B, C, then what is the area of the triangle that is formed by the sides, formed by the points A, B, C, where A, B, and C are the position vectors of them. Don't say you forgot. Half into magnitude of
AB cross AC.
Cross AC.
AB cross AC. So for AB cross AC, wherever cross product comes, what do we use? See, wherever cross product comes, are you sitting and using the big formula, or will you simplify it in a smaller way and go?
Determinant.
You use a determinant method, right? That idea comes from here. So that tells you that area of a triangle can be found using the determinant method. How do you do this? Answer is very simple. Similarly, if you need to do the problem using determinant method, then it is half into determinant of, what should you write? If this is x1, y1, this point is x2, y2, and the third point is x3, y3, then it will be x1, y1, 1, x2, y2, 1, x3, y3, 1. So if you calculate the area of the triangle in any of the methods, everything will give you the same answer. Okay, I am repeating it again. Next time onwards, when you're studying, remember that coordinate geometry, whether it is 3D or 2D, it can always be related to vectors, and cross product from the vectors can be related to determinants. All these chapters are interconnected, so don't read them like separate chapters. So this part, I hope you can solve it, right? So according to this problem, what should I do? Half into determinant of 3, 8, 1. Similarly, minus 4, 2, 1, 5, 1, 1. This you guys can solve it. So whatever you are going to get, if it is a positive value, leave it as it is. If you're getting a negative value, take the modulus of it. Right? So does it make sense?
Yes.
Right? So everything is
Yes,
interlinked,
sir.
right? Yeah. So that's what they have told again, same story. Since area is a positive quantity, we always take the absolute value of the determinant. If area is given, use both positive and negative values of the determinant for calculation. The area of the triangle formed by the three collinear points is 0. So what are they meaning by the second point? If area is given, use both positive and negative value of the determinant for calculation. So what kind of a problem is possible in that scenario? For example, if they give you a question like this, 3, 8, minus 4, 2, and 5, y. Okay, find the value of y such that the triangle formed by all these three vertices is having an area of 5 square units. Then what will you do? You'll use the determinant method, right? So when you use the determinant method, what will be the output on the left hand side? You'll use the determinant method and equate it to 5, right? So determinant of that matrix is equal to 10 because this 2 will go to the other side, right? Once it goes, when you solve this determinant, what are you going to get? You will get a linear equation in what variable?
One variable.
So you will get a linear equation in this variable y, right? So once you get the linear equation in that variable y, you should not write that y is equal to 10 alone. Rather, you should write it as
Plus or minus.
plus or minus 10. See, for example, it comes out like this: 3 plus x plus y. Oh, sorry, 3 plus. Okay, let's say it is coming out as 7 plus y. So 7 plus y, you should not leave it as 10. 7 plus y should be written as plus or minus 10. So from this, you have to solve it as 7 plus y is equal to 10 and 7 plus y is equal to minus 10. So you will get two values of y for which the area of the triangle will have the same magnitude. Okay. Similarly, the third point is the area of a triangle formed by three collinear points is 0. Right. So when you have to, let's say there are let's say you have to prove that 3 points are collinear, what will you do?
Equate the area to 0.
You have to find the determinant and equate the determinant to 0. If the determinant comes out to be 0, you have proven it right, or else they are not collinear. That's it. Right? So I hope everybody knows. Is there any doubt?
No, sir.
All right. Okay, I'm proceeding. So the next important concept in this chapter is the concept of minors and cofactors. So what do you mean by them, guys? So if I have to speak about, if I give you a matrix, okay. So since this comes under the concept of determinants, this minor and cofactor are the parameters from which actually the determinant concept can be defined. Okay, that's why they have told in the section we will learn how to write the expression of determinant in compact form using minors and cofactor. I'll tell you how to do so, don't worry. So first we need to understand what a minor is. So if I give you a matrix like this, A11, A12, A13, A21, A22, A23, A31, A32, A33. If I ask you what is the minor of the matrix A21, what will you say?
A12, A33 minus A32, A13.
Okay. So are you saying minor is a number or a matrix?
Number.
It's a number, right? So let's read out. So minor of an element Aij from a determinant is the determinant obtained by deleting its ith row and the jth column in which the element Aij lies. Minor of an element Aij is denoted by Mij. So Mij, for example, if I ask you what is the minor of, let's say 2, 1. If I ask you what is the minor of 2, 1, what will you say? You have to hide this row and this column. With the remaining matrix, you have to find the determinant, that is A12 into A23, sorry, A33 minus A13 into A32. You have to find the value of this. Rather, what I will do, first I will write it like this. You need to form a determinant like this. That is determinant of A12, A13, A32, A33. I hope this makes more sense, right? So A12, A33 minus A13, A32. So this is going to be the minor of 2, 1. So do we take the sign into consideration here? Are we concerned about the plus, minus and all those things?
No, sir.
Which we are not concerned about, right? So similarly, for the sake of practice, if I ask you what is the minor of M32?
A11, A23 minus A21, A13.
1 minute. A11,
A23
A23.
A23, yeah.
minus A13, A21.
Why are you saying minus? You're directly telling. You're telling the product.
Yes, sir.
Okay. I thought you're telling the determinant form. So A11, A13, A21, A23. So A11, A23 minus A21, A13. Right? So this is a very simple concept. So find the minor of element 6 in the determinant. How to do it? So element 6 means hide this and hide this. What is it going to give us? So M, what should I write for that? M, what is the suffix?
2, 3.
M23 is equal to determinant of 1, 2, 7, 8. That will give you how much? 8 minus 14. That is minus 6. So that is M2. That is the minor of element. So minor of an element of a determinant is the determinant of order n minus 1. What they're trying to say is, if the given determinant is of the order 3 by 3, then the minor of any number from that determinant will be of order 2 by 2. It will be n minus 1. Suppose I give you a 4 by 4 determinant. 4 here, 4 here. If I give you 4 by 4 determinant, if I ask you to find the minor of each element, what will you say? What will be the order of that minor?
3
3
by
by
3.
3.
It will be 3 by 3 order. Okay. You can actually find this, but they're not there in your syllabus, so don't worry about it. Okay. I hope minor is clear. So one point to be kept in your mind, minor is going to give you a number. A positive number or a negative number, that is not our concern, but it will give you a scalar value. The next is cofactor. So cofactor of an element is what? So cofactor of an element Aij is denoted by capital Aij. So capital Mij represents minor, capital Aij represents cofactor. In such a way, how is it related to minor? Aij will be negative of 1 raised to the power of I plus j times the minor of that number. So minor is a number multiplied with minus 1 power I plus j will be the cofactor, right? And tell me one thing, cofactor, will it give you a number or a matrix again?
Number.
It is again going to give you a number only, right? So with this idea, if I ask you, find the minor and cofactors of all the elements in the determinant, how will you do? So if I want to find the minor of 1, 1, what is it? I should hide that row and it is 3.
3.
Minor of 1, 2. Minor of 2, 1. Minor of 2, 2. Minor of 1, 2 is
4.
4.
Yes, that is 4. Minor of 2, 1 is
Minus 2.
Minus 2.
2, 2 is 1.
1.
Next is A11, A12, A21, A22. So what is A11 guys?
3.
It is 3. A21. So actually, let's make it a practice. Minus 1 power 1 plus 1 times 3. That is 3. Minus 1 power 1 plus 2. 1 plus 2 times 4. That is
Minus 4.
Minus 4.
Minus 4.
Similarly, minus 1 power 2 plus 1 times the minor. That is minus 2. How much is it? It's plus 2. A22 is how much?
1.
Minus 1 power 2 plus 2 times 1. That will give you 1. Okay. Now, I'll ask you a question, guys. Okay, let's take this. Find the minor and cofactor of the elements of the determinant. So M11, M12, M13, M21, M22, M23, M31, M32, M33. Right, M11 is how much? Determinant of 0, 4, 5, minus 7. M12 is the determinant of 2, 5, 1, minus 7. M13 is the determinant of 2, minus 3, 1, 5. M21 is the determinant of?
Sir, M13 6015.
Oh, sorry, 6015.
Sir, for M12, it is 614 minus 7, sir.
1 minute, 1 minute. Yeah, 6, 4, 1, minus 7. Sorry. 6, 4,
1 minus 7.
1 minus 7. Yeah. Similarly, for 5, 6, 0, 1, 5.
6015.
1, 5.
Yeah. Now, M21 is how much?
Minus 3, 5.
3 minus 3, 5, 5 minus
5
7.
minus 7.
Minus 3, 5, 5, minus 7. Right. M22 is?
6, 4. 1 minus.
Sir, is it
Yep.
2, 5 and 1 minus
minute.
7, sir?
It is 2, 5, 1 minus 7. It is 2, 5, 1 minus 7. Similarly, what is M23? M23 will be this one.
2 minus 3, 1, 5.
2 minus 3, 1, 5.
1, 5.
1, 5. Similarly, M31 is
-3,504.
see, I'm not verifying it's right only, no, -3, 5, yeah, 0, 4, yeah. M32,
2564.
564.
M33,
2 minus 360.
2 minus 360, right? So what will be the answer for this?
Sir,
It will
is it
be
-350?
1 minute. -7, huh? 2 minus 360 only.
Okay, sir.
Yeah, 2 minus 360. So it is -20. What is the answer here? -42 minus 4, -46, 30, 21 minus 25 minus 4, -14 minus 5 minus 19. This one, 10,
13.
13.
13, -12.
18.
No, it's -12 only, no?
No, sir, M33 is 18.
Okay. So 8 minus 30 is -22. This is 18. Huh?
18.
Yeah. So this is all about minor, right? What can you say about the cofactors? So -22 and 18. Yeah. Cofactors A11, A12, A13. What are the cofactors, guys?
-20.
-20,
46.
A12.
Plus 46.
Yes, it is +4. How did you get that actually?
Sir, I just add 1 plus 2, so 3. So it's
Yeah.
odd.
So -20 minus 1 power 1 plus 2 into. See, every time you need not write it, there is a reason why I'm writing it to explain something. So it is 46. A13 is -1 power 1 plus 3, that is 4 into 30. So -1 power 4 is
30.
130. Similarly, you guys tell me. I don't want to validate it. Just tell me first. A21, A22, A23, A31, A32, A33. You guys tell me first.
4. 4.
Plus 4.
4,
-19.
-19.
-19,
-30,
-13.
-13,
-13.
-12,
Plus 12.
it's minus only, no? Because 3 plus 1, 4.
Okay, sir.
Yeah. Then it is plus 22 and it's plus 18.
18.
Right? So these are the minors and the cofactors. But in the beginning of this exercise, we saw something. What is it? We will learn how to write the expansion of determinant in compact form using minors and cofactors. So with the help of minors and cofactors itself, how will we able to find the determinant? That's the question. So they have asked us to verify something. A11 into A31. So A11 into A31 plus A12 into A32 plus A13 into A33. So how to solve this, guys? What is A11? The first element is 2 and cofactor of A31, -12 plus A12 is how much? -3 into what is A32? 22 plus what is A13? 5 into 18. Let's verify. -24 -66 plus 90. -90 plus 90 is going to give you a 0. Right. Now, I want you guys to find out what is the value of A11 into A11 plus A12 into A12 plus A13 into A13 and tell me. Can you make it fast? So write down this part. I want you to find what is the answer for this and tell me. So what is the answer, guys?
So can you share the screen?
Yeah, just a minute. So A11 into cofactor of A11. So what is the matrix? 2 minus 3, 5, 6, 0, 4. 2 minus 3, 5, 6, 0, 4. 1, 5, minus 7. Tell me, A11 is 2 into cofactor of A11 is
minus
minus
28.
20.
plus minus 3 into A12 is 46.
46.
Yes. A13 is 5 into 30. So how much is the answer? Minus
Minus
40
28.
minus 28. Okay. Now I'll give you another task. Find the determinant of it with respect to the first two and tell me. What is the answer, guys? Is it not still minus 28? Are you able to hear me?
Yes,
Yes,
sir.
Yes, sir.
Is it not still coming out as 90, minus 28? Did you guys get it or not? So I asked you to expand it using the first two. Right? So here also you're getting minus 28, here also you're getting minus 28. So what exactly is the definition of a determinant? So if I have to define a determinant, how am I going to define it properly? Till now we saw only the operations, right? Now we are familiar with the terms like minors and cofactors. Can you tell me what is the definition of determinant? It's right in front of you.
Sum of
Yes. Sum of the numbers,
elements
yes,
and
multiplied with.
cofactors, the same element.
Yes, very good. Determinant is nothing but sum of the numbers, sum of the elements with their cofactors. Right? For example, if I have to expand it along this line, then how will I write the definition? How do I write it in general terms? If I have to expand it along the first column, then how will I write? I can write it as A11 into A11 plus
A21.
A21 into A21 plus A31 into A31. Just to verify the answer, do this and see if you're getting the same answer. So 2 into what is A11 minus 20 plus 6 into A21 is how much? 4 plus A31 is how much? 1 into what is the cofactor of A31? That is minus 12. So minus 40 plus 24 minus 12. So minus 52 plus 28. Is it not still minus 28? Guys, are you able to understand?
Yes, sir.
So the
Yes, sir.
proper definition of a determinant comes from the cofactors of it. So the sum of the elements multiplied with their corresponding cofactors is what is called as a determinant. Okay. So next time onwards, if at all you see this kind of a format somewhere where this number and this number are the same, that is the element number and the cofactors base number, they both are same, and the sum of it is written, then that is represented as determinant. Clear?
Yes, sir.
Yes, sir.
So this is all about minors and cofactors. The next question is about a quantity called as adjoint and inverse of a matrix. Okay. The concept of inverse of a matrix here we are applying to find the solution of a given equation. So actually there should have been another method where you will find the inverse of a matrix using what method? The elementary row transformation or elementary column transformation method. But since it is removed, we didn't discuss it. But yesterday I told you what do you mean by inverse of a matrix? If A is a given matrix, then the inverse of that matrix should be in such a way that when you multiply the matrix with its inverse, you should get an identity matrix. Right? So in the previous chapter, that is what they have told. We have studied the inverse of a matrix. In this section, we will discuss the condition for existence of an inverse of matrix. Okay. To find the inverse of a matrix, that is A inverse, we shall first define an adjoint matrix. Okay. So see, can you people tell me what are the condition for an inverse to exist according to this chapter? Let me see if you guys already know.
The determinant should not be equal to 0.
Yes. So what is the technical name of that kind of a matrix?
Singular matrix.
Singular is determinant is 0.
Non-singular.
Should be a non-singular matrix. Okay. So it is adjoint of A divided by the determinant of A. So inverse is nothing but adjoint of A by determinant of A. Let's see why it is so. So we need to understand what is the adjoint of a matrix. Here we are discussing about a matrix. Okay. It's not about determinant. So what do you mean by adjoint of a matrix? Can you give me a simple definition to it? It is a transpose of something. Fill in the blank. Transpose of dash matrix.
Cofactor.
It is a transpose of cofactor matrix. As simple as that. Means if a square matrix, so adjoint is also again defined only for a square matrix, obviously. Okay. So the adjoint of a square matrix is defined as the transpose of the matrix, the transpose of the cofactor matrix. So if the matrix A11, A12, A13, A21, A22, and A23, A31, A32, and A33 are given, what is our work? First, find the cofactor matrix. See, cofactor is actually a number. What do you mean by cofactor matrix? Taking all the corresponding cofactors of the elements and putting them in the form of a matrix is called as cofactor matrix. Okay. So they are nothing but A11, A12, A13, A21, A31, A22, A23, A32, A33. Okay, this is the cofactor matrix. To find the adjoint, what are we supposed to do? Just take the transpose of this. So adjoint of A is represented as ADJ A is equal to transpose of cofactor matrix. That is, you guys tell me, A11, A12 will come. So the rows will become columns and the columns will become rows.
Sir, A13, sir, the bottom.
Oh, sorry. A13. Oh, here also I wrote it. It's 13. Yeah. A13, A22. Here it is A33. Here it will be A32. And here it will be A23. Right. This is what is adjoint. Right. So for a
Sir,
square
can you
matrix,
repeat this, sir?
did I repeat something? You want me to
Sir,
repeat the
can you
concept?
repeat this? Yes, sir.
Okay. See, you understood what is a cofactor, right?
Yes, sir.
Right. So for A11, if you find the cofactor, see, this is the element. This is the cofactor, right? So for the element A11, the cofactor will be capital A11. Similarly, for A12, it will be capital A12. You'll find for this matrix, how many cofactors will you find? So how many elements are there?
9
9.
cofactors.
9. So you'll find 9 cofactors, right? So those 9 cofactors, can you arrange it in a 3 by 3 format?
Yes, sir.
So how are you supposed to arrange this? For the element A11, the corresponding cofactor is capital A11. So A11 cofactors matrix should contain the cofactors of the element. So A11, then capital A12, capital A13. Similarly, capital A21, capital A22, capital A23. Similarly, capital A31, A32, A33. This, are you clear till this point?
Yes, sir.
So this is the cofactor matrix. So first find the cofactor matrix. Then if you find the transpose of it. So what do you mean by transpose? Transpose means interchanging the rows with columns. So the diagonal element will not change. A11, A22, A33 will be the same. So A12 will come here, A21 will go here. So A12. Similarly, A13 and A31 will get exchanged. Am I clear? Are you
Yes,
able to
sir.
understand? So if you write the transpose of the cofactor matrix, then it is given a technical name called as adjoint of the given square matrix. Clear? So what are the steps to be followed to write the adjoint? From the given matrix, first find the cofactors, write the cofactor matrix, then find the transpose of it. That will give you the answer. Right? So for solving purpose, let's try to do this problem. Find adjoint of A for A is equal to 2, 3, 4, 1. A11, A12, A21, A22. So what is A11? Minus 1 power 2, it is 4. Minus 1 power 3, 1.
Minus 1.
Minus 1 power 3,
3.
3. So minus 1 power 4, 2. Right? 4 minus 1 minus 3. Right? 4 minus 1 minus 3, 2. So how will you write the cofactor matrix in this case?
4 minus 1 minus 3, 2.
4 minus 1 minus 3, 2. What is the transpose of this?
4
4
minus
minus 1.
3.
4 minus 1.
Yes. So the left side diagonal elements will be the same. Right side diagonal elements will get exchanged. 4 minus 3 minus 1, 2. So this is the adjoint of a 2 by 2 matrix that is given. Okay. So based on the observation, what has happened is, see, if you observe 3 and 1, their sign has changed. And 2 and 4, the numbers got changed. Right. So this is the given value. What is the final output? The final output is in such a way that the right diagonals, so right diagonals sign alone has changed, left diagonals elements have changed. So that is a shortcut in which you can write. So that's what they're given in the textbook. If at all you want to do it also, it is going to take less than 2 minutes. You can do it fast also, but just for understanding. So for a square matrix of order 2, the elements given are A11, A12 and A21, A22. Then for you to write the adjoint, what you're supposed to do is A11 and A22, the numbers are supposed to be interchanged. For A12 and A21, the sign is supposed to be changed. That's it. So the final answer will be A22, A11 minus A12 minus A21. So it is clear that adjoint is always a matrix. Right? Guys, is it clear? Shall I proceed?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So next we will write, so we will see some theorems. So if A be any given square matrix of order n, then if you multiply the matrix with the adjoint of that matrix, then it is the same as adjoint of that matrix times A. Here we are able to do it because A is also a 3 by 3 matrix, adjoint of A is also a 3 by 3 matrix. Since both are square matrix of the same order, so of course we can, so when both the matrices of the or square matrices of the same order, what can we do? We can follow the commutative law also. A into adjoint of A is the same as adjoint of A into A is given as determinant of A times I, where I stands for what? The identity.
Identity matrix.
So this is one of the theorems. So these are all the theorems without proof. If you ask me how they have actually come, it is based on the observation. Okay, this chapter is mostly based on the observations. So you can remember this property. A into adjoint of A is the same as adjoint of A into A is the same as determinant of A into identity matrix. So determinant of A is a number. Number multiplied with that identity matrix will give you the answer. Okay. Since this is happening, A into adjoint of A is equal to delta into I. Remember this. Okay. Remember this theorem. From this only, from here only, we will talk about the inverse. Next, the definition number 4. So if you have a square matrix A, it is said to be singular if the determinant of that matrix is 0. See, for example, there is a matrix given 1, 2, 4, 8. If you calculate the determinant of it, it is going to be 8 minus 8, which is a 0. So it is a singular matrix. So the exact opposite of it is going to be a non-singular matrix. That is the definition number 5. So if you have a square matrix A that is said to be non-singular if determinant of A is non-zero. For example, A is equal to 1, 2, 3, 4. Take the determinant of A. Determinant of A is 4 minus 6, that is minus 2, which is a non-zero number. So it is a non-singular matrix. Right. These are all simple points. Next. The theorem number 2 is, so theorem number 1 says A into adjoint of A is equal to adjoint of A into A is equal to determinant of A times identity matrix. And theorem number 2 states if A and B are non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. Okay, all these theorems go without proof. If you have two non-singular matrices in your hand, A and B, that is, their determinant is not equal to 0, and they should be of the same order. Then what is the conclusion? The conclusion is the product of these two, which is AB, and the reverse product BA, if you try to calculate the determinant of both, then they will also come out as a non-zero value. Okay, this is the conclusion that we can have in our mind. Maybe this kind of a question can come in theory based, like they can give you different options and ask you. Next. Am I clear? No confusing point, right? Shall I proceed?
Yes, sir.
Yeah. So the determinant of the product of matrices is equal to product of their respective determinants. That is, if you have two matrices A and B, if you do AB, you do the product of them and calculate the determinant, that is the same as determinant of A and determinant of B, where A and B should be obviously square matrices for determinants to be defined, and they should be of the same order. Clear? So this is another point. Okay. The next is, if A is a square matrix of order n, then you find adjoint of A, or you find the determinant of adjoint of A, and you find the determinant of A separately, then the relation between both is determinant of adjoint of A is equal to determinant of A power n minus 1, where n stands for the order. This is also another important condition. Okay. So please make a note of it. This is a very, very important condition. You will get 1 mark questions many times based on this. Okay. Shall I proceed?
Yes, sir.
Now comes the question of inverse. So if there is a square matrix A which is invertible, when I say invertible, it has to be what? It has to be a non-singular matrix, because the inverse of A is always defined in terms of adjoint of A, adjoint of A divided by the determinant of A. Let's see the proof of it. It's a simple one. So let A be an invertible matrix of order n and I be an identity matrix of order n. Okay. If that is the case, then what is the relation between A adjoint of A, det A, and I? According to theorem number 1, what is the relation between A adjoint of A, determinant of A, and I? This is the relation. A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Okay. So since determinant of A is a number, can I divide with that on both the sides?
Yes, sir.
Right. So here observe. So what they have written is A into adjoint of A divided by determinant of A is equal to 1 by determinant of A into adjoint of A into A is equal to I. That is this number. You have divided both the sides with that number. So when you do that, see, you're able to understand one thing from here, one important point. What is the definition of inverse actually? If I have a matrix A, if I have to call a matrix B as its inverse, then the product of A and B should give me an identity matrix, or the product of B and A should give me an identity matrix. Here, what is happening? This is a very, very important step. A into, if I call this whole thing as matrix B, similarly, if I call this whole matrix as B, since A into this whole matrix B is giving me an identity matrix, can I call B as an inverse of A?
Yes, sir.
Right. So then B will be equal to A inverse. But what is B? What is that we have substituted as B? That is nothing but adjoint of A divided by determinant of A in both the cases. So that is the reason why using adjoint method, this has come out as a formula. Clear? Right? Now see. So if I take a matrix A is equal to 1, 3, 3, 1, 4, 3 and 1, 3, 4, then we need to, then they're asking us to verify A into adjoint of A is equal to delta into Y. Is this condition satisfied or not? Okay. Once you find whether it is satisfying or not, you need to find the inverse of it. Shall we do it? So for us to find the adjoint of A, we'll find the cofactor matrix. So can you guys tell me what the cofactor matrix? Plus, minus, plus, minus, plus, minus, plus, minus, plus. I'm doing it directly, okay? For 1, that is the first element 1. What is the cofactor?
7.
7. For 3, it is minus 1.
1.
For this 3,
Minus 1.
yes. For 1, it is minus of 12 minus 9, 3. For 4, it is plus, hide this row and this column, it is 4 minus 3, that is 1. For 3, it is minus of how much?
minus 1 plus 1.
So
Minus of hide this and this. So 3 minus 3 is 0, no? So plus minus plus minus plus minus plus minus plus. So for this one, what is the cofactor?
Minus 3.
Minus 3. For this, it is minus already present.
Nine.
Check it properly.
0.
Yeah, it is 0. For 4, it is minus again because sorry, it is plus only. A33, no? 6. Yeah,
1.
that's it. So what will be the adjoint of A? 7
7
minus
minus
1.
3.
Yeah, you are telling the row. Yeah, 7 minus 3 minus 3. Minus 1, 1, 0. Here you have a 1. Here also it is 0. Okay. Now what is A into adjoint of A? So what is A into adjoint of A? Is there anyone who is not able to understand? So A is 133, 143, 134. Adjoint of A is 7 minus 3 minus 3 minus 1, 1, 0 minus 1, 0, 1. So 1 into 7, 7 minus 3 minus 3. Then minus 3 plus 3 plus 0. Minus 3 plus 0 plus 3. 7 minus 4 minus 3. Minus 3 plus 4 plus 0. Minus 3 plus 0 plus 3. 7 minus 3 minus 4. Minus 3 minus 3 plus 0. Minus 3 plus 0 plus 4. So 7 minus 6, 1, 0, 0. 7 minus 7, 0. Here also 0. Here it is 1, 0. Here you should definitely get a 1. Here it's 0. So there is nothing but identity matrix. So A into adjoint of A is equal to determinant of A into I. That is what they are asking. So what is the determinant of A, guys? What is the matrix? 1, 3, 3. Okay, I have it here now. So this is the matrix. So 1 into 0 minus 3 into 1 plus 3 into minus 1. It's coming out as minus 6. Minus 3 into 4 minus 3, that is 1. 3 into 3 minus 4, that is minus 1. But that's not, no? That's not what is A into adjoint of A. What has gone wrong? So 1 into 0, 16, 16 minus 9. 16 minus 9 is 7. Yeah, here it is 7. So what is it you're getting? You're getting it as 1. So 1 multiplied with this identity matrix is nothing but A into adjoint of A. Right? Hence we proved it. Similarly, what is A inverse? A inverse is adjoint of A by determinant of A. We need not separately solve it. Determinant of A is 1. What is the adjoint of A? 7 minus 3 minus 3. This one. 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. Am I clear? So how to verify whether this is the inverse or not? What you're supposed to do is you have this matrix, right? Multiply this matrix with 7 minus 3 and minus 3, this thing, then it should give you an identity matrix. That is what we are getting actually. See, fortunately, what happened, since here the determinant is 1, here the A inverse is nothing but adjoint of A only. Okay, that also got proved. So when you multiply the given matrix with the inverse of it, you should get an identity matrix. Guys, am I clear? Is there any confusion?
No, sir.
Fine, right? Okay. Similarly, you have A and B. They're asking you to verify AB inverse and B inverse A inverse and verify whether they both are same. So for AB inverse, first multiply A and B. You will get something. You will get a matrix. Then find the inverse of it. Similarly, find inverse for B separately, find inverse for A separately. Then multiply these two. The output here should be equal to second. I hope you guys will be able to do it. Yes or no?
Yes, sir.
Yes, sir.
So all these things are based on inverse only. I will explain the concept, then we can do the remaining problems. So applications of determinants and matrices. So in this section, we will discuss the application of determinants and matrices for solving the system of linear equations in 2 or 3 variables and for checking the consistency of the system of linear equation. So you can say a system is consistent or inconsistent depending on the number of solutions it has. A system of equations is said to be consistent if its solution, that is, if it has one or more solution existing for them. It is said to be inconsistent if its solution does not exist at all. Okay, the mostly that will not exist in the case of singular matrices. Okay, let's see what they are. So solution of system of linear equations using the inverse of a matrix. So suppose they give you 3 linear equations like this. How are you going to solve it? A1x plus B1y plus C1z is D1, A1x plus B2y plus C2z is D2, A3x plus B3y plus C3z is equal to D3. Right? So I told you already, whenever you have linear equations in your hand, you can write it as coefficient matrix into variable matrix is equal to constants matrix. Right? So what can we do? You can write A1, B1, C1. The first row should contain the coefficients of the first equation. A2, B2, C2, A3, B3, C3 multiplied with the column matrix XYZ, which is the variable matrix, should be equal to the column matrix, which is C constants, D1, D2, and D3. So how will you find the value of XYZ? It's very simple. What you need to do is, if I call this matrix as A, then this XYZ matrix is called as capital B. If this constant matrix is called as D, then the matrix capital X, that is the variable matrix, will be equal to A inverse multiplied with B. So if you do this operation, then by equating both the values, you can find the value of X, Y, and Z. Okay. So what will happen is, there will be 2 cases possible. If A is a non-singular matrix, then its inverse exists. So if AX is equal to B, I wrote it as D, they wrote it as B, that's it. So by pre-multiplying with A inverse on both the sides, A inverse of AX is equal to A inverse of B. So what is A inverse of A? A inverse of A is the identity matrix
Identity matrix.
multiplied with X is equal to A inverse of B. Identity matrix, any matrix multiplied with its identity matrix you will get back the original matrix. That is X. So X is equal to A inverse of B. That's what I wrote here. Okay. So this matrix equation provides unique solution for the given system of equations as the inverse of the matrix is unique. So this method of solving system of equations is known as matrix method. Actually, you can do it using basic algebra also. But here we are trying to use matrix method. We are learning a new method. That's it. It's a tool. That's it. So case 2. If A is a singular matrix, then the determinant of A is 0. Right? In this case, we calculate adjoint of A into B. Then if adjoint of A into B is not equal to 0, where is not equal to O, where O being a 0 matrix, then the solution does not exist and the system of equations is called as inconsistent. If suppose the adjoint of A into B comes out to be 0, the system may be either consistent or inconsistent according to the system having either infinitely many solution or no solution. So we need not worry about this part. We'll look into this part. Okay. So when they say solve the system of equations, what you can do is, since you know the elimination method, first find out what is the solution. Okay, first find out what is x comma y. Then when you use a matrix method and solve it, you need to ensure that both the answers are matching. So how will you solve using matrix method? 2, 5, 3, 2 multiplied with xy is equal to 1,
1.
1, 7. So matrix xy will be equal to, if I take this matrix A as this matrix as A is equal to 2, 5, 3, 2. Is it a singular or a non-singular matrix?
Non-singular.
Non-singular.
It's a
Non-singular.
non-singular matrix, right? So the determinant is going to come out as 4 minus 15, which is minus 11. So since it is not equal to 0, I can write matrix x comma y is equal to A inverse of 1, 7. So you know how to find the value of A inverse using adjoint method. So A inverse is equal to adjoint of A divided by the determinant of A. Find it using the adjoint method and then substitute it here and multiply both. That will give you the required answer. Will you be able to do it?
Yes, sir.
So what if the determinant comes to be equal to 0, sir?
Determinant comes out to be 0, then you cannot find solution for it.
So we can directly tell that there are no solutions.
Yes, you can say.
Okay.
Okay. Similarly, this also you can solve it. X is equal to A inverse of B. So I will write the outline alone. 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2 multiplied with x, y, z comes out to be 8, 1 and 4. Then first find whether it is a singular or a non-singular matrix. If it is singular, solve it. Non-singular, you can stop it. Sorry, if it is non-singular, you can solve it. Singular, stop it. Okay. So this is all about determinants also. So first two exercises, they are easy only. The last one is there, which involves this inverse and all. I suggest you guys to practice that. If you have any doubts, you can approach me. You have the other number, right? You can approach me personally. So depending on the request, I will solve the problems in the class. If you have individual doubts, you can approach me. If many of them are asking, I will definitely do it in the class itself. Okay. So I went little fast, assuming that you have already written test in this chapter. But if there are doubts, you can always feel free to ask. Don't worry about it. Okay. Just wait for a minute, guys.